I had this problem on the board. Let's review how to do this problem, and then we'll talk about some of the ways we can use systems of equations to solve word problems. That's what we're going to be doing today. And then we're going to be starting talking about how to work with polynomials. That's going to be the next week and a half worth of work. Okay, but let's look at this problem. We have two equations, negative 2x plus y equals negative 1. And also we have the second equation, y equals negative 4x plus 8. It is a system of equations. So therefore, if we want to solve this system of equations, we have two options. Well, actually, we have three options. We could graph it, but we said we're only going to use a graphic method if they specifically tell me I have to use the graphic method because it's long and it's sometimes not very accurate. I'm going to just, right now, I'm going to mute everybody. If you want to, you can always unmute yourself. But let's just to keep it quiet in the, if somebody comes on. Okay, so I'm going to use either the elimination method or the substitution method. Now, really, the way I see it set up, where I see the second equation that's saying explicitly y equals negative 4x plus 8, that type of example, I usually like to do using the substitution method. I'm going to do it first by the substitution method, and then I'll go back. If you really don't like the substitution method, you could always use the elimination method, and I'll show you how to do it with that. Okay, if we're using substitution, I'm going to go to my first equation, and where I see the y in that first equation, I'm going to replace it. I'm going to substitute for it negative 4x plus 8. So my top equation will become negative 2x plus, well, now here's my y. Now my y, instead of putting y, I'm putting negative 4x plus 8. And that's going to equal to negative 1. Now, there's nothing in front of this this parentheses, so when I want to remove the parentheses, I can think of it as if there's a 1 there, and there's an imaginary 1. And therefore, when I use the distributive property, I'll just get negative 2x. Negative 1 times negative 4x is negative 4x. 1 times 8 is 8, and that equals negative 1. Alternatively, we could remember anytime there's a plus in front of a parentheses, no number, just a plus, you can remove the parentheses. And anytime there's a minus in front of parentheses, you just change all the signs to remove the parentheses. But again, you could always think of it as if there's that 1 standing in front of the parentheses, just like if you have a plain x, it really means 1x. Okay, combining the like terms here, we get negative 6x plus 8 equals negative 1. And I will subtract 8 from both sides, which will give me negative 6x equals negative 9. And divide both sides by negative 6. And I get negative 9 over negative 6 as my value for x. Of course, we can reduce it. First of all, negative over negative becomes positive. And I can divide both the top and bottom by 3. So 9 divided by 3 will be 3. And 6 divided by 3 will be 2. And again, negative over negative is positive. So my value for x is 3/2. The x equals 3/2. How do we figure out what the y is? Well, let's go over here. My y, I know, is negative 4x plus 8. So therefore, I'm going to replace the x with 3/2. That'll give me y equals negative 4 which I'll put over 1 because I'm going to be multiplying it by a fraction, times 3 halves plus 8. So here's what my y is. Negative 4 over 1 times 3 over 2. The 2 from this denominator can cancel out into the negative 4. That'll give me negative 2. And negative 2 times 3 is negative 6 plus 8, which gives me a positive y equal to 2. You could also, when you're multiplying, you could have just taken your calculator and done negative 4 times 3 divided by 2. That will give you the negative 6, and then negative 6 plus 8 will give you the 2. So your system of equation solution is 3 halves, comma, 2. Does anybody have a question about that? Anybody want to ask me something? Okay, so I'm going to go back and show you, if you didn't like this substitution method, you really could have done this using the elimination method. Let me show you how that would have worked. I'm going back as if I remember here. I'm just going to put my answer over here so that I remember. I'll show you that you will get the exact same answer. Okay, here we are. Starting this problem, just as a review of the elimination method. My top equation is negative 2x plus y equals negative 1. I'm going to go right over here. Negative 2x plus y equals negative 1. Here's what equation number 1. My second equation is y equals negative 4x plus 8. Now, if I want to use the elimination method, it's not in the right format. I need to put it in what we call standard format. I have to get the negative 4x to the other side. So I have the x's and y's together. So my second equation will become 4x plus y equals 8. Here is equation number 2. 4x plus y equals 8. Now you have your choice. Let's say we decide we want to get rid of the y's. We usually get rid of the x's. I'm just doing, let's do the y's. It doesn't matter. You can get rid of whichever variable you want. Well, if I look at it, the coefficient of the y in the first equation is 1. So I'm going to have to multiply my second equation by 1. The coefficient of y in the second equation is 1. So I'll have to multiply the first equation by 1 as well. But since both of these are positive, and I want to end up with one being positive and one being negative, I'm going to multiply one of them. I'm going to use a negative sign with one of them. It could be the first one. It doesn't matter. So therefore, equation number 1 will come out to be negative 1 times negative 2x is positive 2x. Negative 1 times y is negative y. Negative 1 times negative 1 is positive 1. Multiplying the bottom equation by 4x just leaves it alone. It stays 4x plus y equals 8. And when I add these two equations together, 2x and 4x gives me 6x. Negative y and positive y are eliminated. That was the whole point of this, that we're getting rid of the y's. And 1 plus 8 is 9. And then I'll figure out what x is by dividing by 6. And again, reducing this gives me 3 halves. And we're back to over here. And then you find the y exactly the way we've done before. Just substitute the 3/2 into one of the equations. It doesn't matter which one. And it's the same work that we did before, so I'm not repeating it. So we could have done either the elimination method or the substitution method in this particular problem. Remember that, okay, you want me to explain why I used ones. Okay, let me explain that again. I decided I wanted, I'm going back. I'm stepping back again. Somebody asked me a question. I decided I wanted to get rid of the y's. Now, since there's no number in front of the y, each of them, it's as if there's a 1 there. An imaginary 1. If I see negative 2x plus y, it really means negative 2x plus 1y. Now, when I'm using the elimination method, I always multiply each equation by the coefficient of the other, of the variable in the other equation. I want to get rid of the y, so I look in my second equation, the number in front of this y is 1. I've got to multiply the first equation by 1. Similarly, in this equation, I'm getting rid of the y. So what I see in front of the y is 1. That's why I'm using the 1. Again, since both of these were positive, I had to use a negative sign with one of those numbers. So does that explain your question? Are you okay now, Marcus? I think it was Marcus. You okay? Okay, great. I see. Again, if you want to ask me a question, you don't have to, unless you don't, if you don't have a mic it's on your device, then obviously you can't. You have to use the chat. But you can always unmute yourself and ask the question, and that so all of us can hear. Okay, so this is really where we had left off on Tuesday. And I'm going to continue with what we were, where I'm going to be showing you how we can use systems of equations as an application in working out word problems. And I'm going to do basically 2 types. I don't want to overburden you with too many. I'm going to concentrate on the types that you might see on your midterm or final. The last section in the homework, which Amy, actually, this is what you had asked me about, the systems of equations in what they call context, is really word problems. Now, I assigned you to try those, but that really, if you can do them, fine. Don't worry if you can't. The ones that you really have to be able to do are the type that are on practice sheet 3. And as a matter of fact, questions, your homework, I'll just put it up here, aside from what's on Delta Math, will be sheet 3, seven through 10. And of course, whatever else is on Delta Math. Okay, so let's look at some type of problems we might encounter. I'm actually looking at problems from our textbook. These are questions that are section 3.5 if you want to see where more problems like this in your textbook. This it actually happens to be section 3.5, question number 1. And here's what it says. One number is 3 more than twice another, The sum of the numbers is 18. The sum of the numbers, I'm writing it a little bit abbreviated because I don't want to write so much. And we want to find the two numbers. This is a number problem. And it's a number problem that's talking about two numbers. And very often when we're dealing with a problem where we're trying to find out, or there are two different items, there are two different things that we're interested in finding out. Basically, we have two variables that we're looking for. When we want to write an equation, we actually want to write a system of equations because there are two things that we're looking for that will, when we solve it, will give us the answer to this problem. Now, the first thing you have to do, and probably is one of the most important things, is what's called make a legend. What a legend is a decision. I like to write it down, but if you just decide in your head, you have to know what does your variable stand for. You can't write an equation with variables if you don't know what the variables stand for. So first, decide what your variables are going to be and what they represent. So if I look at this question, it says one number is 3 more than twice another. So basically what we have is two numbers. Let's assign x to be the first number and assign y to be the second. Here's my legend. It doesn't need to be very complex. I know that I have two numbers. I'm going to call one of them x. My first one I'm calling x, and my second one y. And I'm going to then read the question in terms of first number and second number, so I can write x and y. So basically one number, let's call it the first number, is 3 more than twice another, that's the second number. So we have one number, 3 more than twice the second number. How do we write an equation? We know how to change English to algebra. Remembering, more, when they say something is more, we add. When we say something is less, we subtract. And remember, these are at the end. 3 more means the number plus 3. 3 less means the number minus 3. Okay, we have 3 more, so we're adding 3. Then twice. Now, what does the word twice mean? That's an English word, but obviously it really means 2 times. So we're going to be multiplying. So my first number, my x, is 3 more, so I'm going to be adding 3 at the end. Then twice the other, the first number. So it's going to be 2y. Twice means multiply by 2. So I have changed this statement from English to algebra. We only have one equation, but we have two variables. We need a system of equations. We need 2 equations. So I go to the further information. The sum of the numbers is 18. Well, we know when it says sum, what we're doing is we're adding. So that means that we have x plus y equals 18. I have now changed my verbal problem into an algebra problem, into a problem that is a system of equations. Now I'm going to give you a couple of minutes to try and solve this system of equations on your own. Okay, let's look at this. And let's see if we can solve it. I think the best way to go on this one is the substitution method, because in this first equation, it explicitly says x equals 2y plus 3. So I can, in place of x in my second equation, replace the x with 2y plus 3, and that's exactly what I'm going to do. Over here, where I see the x, I'm going to put 2y plus 3. So I get 2y plus 3 plus y equals 18. And 2y and y can be combined to 3y. So I get 3y plus 3 equals 18. So that gives us 3y equals 15. And dividing by 3 gives me y equal to 5. And since I know that y equals to 5, I can now take this equation and say x equals 2 times, well, my y is 5, plus 3, which gives me 10, plus 3 is 13. So we get that my first number is 13, and my second number is 5. Notice they do add up to 18, which is what we needed them to do. So here's how we take a verbal problem and translate it into a algebraic system of equations and solve it to get our answers. Okay, let's try another example. This is what's a standard number problem. It talks about numbers. And I'm going to do a type of problem that's different, but we're going to see a lot of the next type of problems. This actually, I'm again taking it off out of the textbook, and it's question number 11 in section 3.5. Here's what it says. Linda sold $925 tickets for her choir's concert for a total of $6,000. Well, I didn't put in for the concert. It doesn't matter what the tickets were for. She sold tickets for some event. She sold 925 of these tickets, and she got $6,000. Now, there were two different types of tickets. Adult tickets were $8. And children tickets were $6. And we want to know how many of each type of ticket did she sell. We know altogether she sold 925 of them, but how many were children's tickets and how many were adult tickets? And again, here is a situation where we have two types of things, and we want to know how many of each type we are going to be getting. And this could be tickets for any kind of affair. It could be not just tickets for something. It could be, we could talk about how much People are buying, let's say she's the, I'm trying to think another type of situation. Yeah, somebody sells two types of shirts in his store, and one costs one amount and one costs another amount. And we know how much he gets all together for all the shirts, but how many did he sell of each type of shirt? In other words, this is a common type of word problem. And we're going to set it up, and you're going to see the setup is pretty similar to all these word problems. Okay, again, we have to set up a legend. We have to decide what our variable is going to represent. Now, I'm going to use X and Y, but you can use A for adult and C for children if you prefer that. Any two variables will work. Okay, what are we looking for? Once we know what we're looking for, then we can write our legend. Then we can decide what our variables stand for. So the question was, how many of each type of tickets did she sell? So she had, let's call X the number of adult tickets that she sold. I'm not writing just adult tickets because there are a lot of things that adult tickets could mean. I'm being specific. How many adult tickets did she sell? That's one question. Our second question is the number of children's tickets that she sold. So here are my two variables. I look at what I'm asked for and use that to decide what my variables will be. My two variables are X, meaning how many adult tickets were sold, and Y, which is how many children's tickets were sold. Now, let's go back to the facts, and let's take it slowly. Linda sold 925 tickets. Stop right there. That's one idea. What equation can I write from the fact that Linda sold 925 tickets? Well, if X is how many adult tickets she sold, and Y is how many children's tickets she sold, then X plus Y, the sum of them, is how many she sold altogether. So the X plus Y has to equal to 925. Notice 925 has nothing to do with how much each ticket cost. It's just a total. So I don't use anything that has to do with money on that first equation. Now we go to the second fact. She sold all these tickets and she got $6,000. Now, how did she get this $6,000? Well, by selling adult tickets for $8 and children's tickets for $6. So let's think, how much money did she make on the adult tickets? Well, if you take X, which is how many adult tickets she sold, you have to, let's say she sold 100 adult tickets, and each one of them is $8. The way you find out how much it is you take the number of tickets and multiply it by the price. 8 times 100. She would get $800 for 100 adult tickets. We don't know how many adult tickets she sold. We know it's X. So the amount of money she got for selling adult tickets is 8X. The amount of money, similarly, that she got for the children's tickets is 6 times the Y, because Y is how many children's tickets there are, and each of those were $6. Now, if you take the 8X and the 6Y, that is going to give you your $6,000. Notice my first equation talked about how many tickets there was. It had nothing to do with money. I didn't include anything in there that had money. But once we start talking about the money, how much money she made, I have to include the prices of the tickets. Now, here's my system of equations. Again, I'm going to leave you a couple of minutes. Let's see if you can solve the system of equations. And I'm going to, again, we're going to have to use a negative with one of them. Let's use a negative with this one. So let me see if I can move this over a little bit. So this equation is going to become negative 8x minus 8y. I'm distributing that 8. And I have to multiply 925 by negative 8. Well, guess what I'm doing? I'm taking out my calculator. I don't want to have to do that in my head or with long. I want to do it as quickly as I possibly can. Negative 8 times 925 gives me negative 7,400, 7,400. Remember, we're multiplying the bottom equation by 1, so it'll stay 8x plus 6y equals 6,000. And now I add these two equations together. The x's are eliminated. We're using the elimination method. The negative 8y and the 6y gives me negative 2y. The negative 7,400 plus the 6,000 gives me negative 1,400. And I'm going to divide both sides by negative 2. So that gives me that y is equal to negative 1,400 divided by negative 2 is positive 700. So the first thing I found is that y is equal to 700. That means she sold 700 children's tickets. How many adult tickets did you sell? Well, I'm going to go back over here. I know from my original equation that x plus y equals 925. So therefore, in place of the y, I'm going to put 700. So I get x plus 700 equals 925. And if I subtract 700 from both of them, this will give me x equals 225. So we have 225 adult tickets that she sold and 700 children's tickets that we sold. And notice we used a regular system of equations. We wrote a system of equations and we solved the system of equations. Let's see. I see a couple of. Okay, I see everybody's okay. Yes, you are totally correct, Evelyn. Okay, let's try. I'm going to give you one to try on your own. Oh, great. Amy, did you want to ask me your question now? Or do you think you understand?
No, I can't understand it now. It was just about the plotting that I had a question with.
Okay. So I'm going to give you another question similar to this to try. Okay. I'm going to erase this and give you another one similar to this. Again, remember really what you have to do, there are 4 questions on the practice sheet 3, which are the type that you will can expect to see on your midterm and final. Okay, this is also from the textbook, it's question number 12. And it says this, Jared was selling tickets to ride the Ferris wheel. I'm not putting the whole thing, I'm not writing that it's a Ferris wheel. It doesn't matter what he's selling tickets for. He's at a local carnival. Okay, so the fact that he sold tickets for the Ferris wheel is just icing on the cake. You really don't need that for the problem. Here's what the tickets cost. The tickets are $2 for adult, and $1.50 for children. And we want to know, he sold a total of 300 tickets, and he made a total of $525. And we want to know if you can write a system of equations to solve this, and then solve it. I will give you a few minutes to try. Okay, it's very similar to the last question. Of course, the numbers are different, but the idea is the same. Again, I'm going to call X the number of adult tickets. And Y the number of children's tickets. Okay? Remember, there's a couple of things you could know about adult and children's tickets. How much they cost. Well, we know how much they cost. And how many there were. And they're asking us how many they were. Always look at your question. That'll tell you what you're looking for. That will help you find what your variable should represent. Okay. Our first step is that we know that 300 tickets were sold. That means the total amount of adult and children tickets is 300. So my first equation becomes X plus Y equals 300. Again, just like before, 300, the number of tickets has nothing to do with how much each of the tickets cost. It's just how many they are. So therefore, X plus Y equals 300. Okay, the next thing has to do with money. So therefore, with money, we have to include the money. So we have 2X, because each of the adult tickets cost $2, plus 1.50 Y equals 525. Here we're going to have to be careful because with money, sometimes you have decimals, as we do in this case. We don't have an exact $2 or $3, it's $1.50. So we're going to have to be careful when we use this number. But again, I have a calculator, so I'll be careful with my arithmetic. Again, let's see. We want to, let's eliminate the x's. If I want to eliminate the x's, the top equation I'll multiply by 2. And again, the bottom equation by 1. Again, I need a negative for one of them so that one will turn out to be negative 2x and one will turn out to be positive 2x. So the top equation becomes negative 2x minus 2y equals negative 600. The bottom equation stays 2x plus 1.50y equals 525. Okay, let's add these two equations. We're using the elimination method. The negative 2x and the 2x cancel out. Now I have to add the negative 2y and the plus 150. Now, you could do that in your head, or you can take out, remember you're allowed to use a calculator. If I use my calculator, I'm going to do negative 2 plus 1.50 and it gives me negative 0.5. Just adding this negative 2 and positive 1.5 gives me negative 0.5. So it's negative 0.5y. And negative 600, I'll do that on my calculator as well. Negative 600 plus 525 will give me negative 75. And now I'm going to divide both sides by negative 0.5. Again, a negative and a negative divided gives me positive. So I'm dividing 75 by 0.5. Again, I'm using my calculator. Why should I do it in my head? And it comes out to be 150. It turns out that Y, which is the number of children's tickets, is 150. They sold 150. He sold 150 children's tickets. How are we going to figure out how much the X is? Well, I'm going to go back to this original equation because that's a simple one. X plus Y, which I now know is 150, equals 300. And if I subtract 150, I get X equal to 150 as well. That's not so surprising because probably each child had an adult going with them. So they sold 150, he sold out of his 300 tickets that he sold, 150 were adult tickets and 150 were children's tickets. And you were completely right, Marcus. I think that was the answer that you gave me, and it was correct. All right, so does anybody have any questions about this? If you notice, the numbers are different, but the type of problem is the same. This is the type of problem you will probably encounter on your midterm or final. Okay, I think right now we did enough of the word problems. I'm going to start with another topic, but before I do, let me remind you, aside from the questions on topic, on homework 4 on Delta Math, there are these, the homework sheet 3, examples 7 through 10. That's much more important for you to be able to do rather than the ones that are in the last section. You can try those in the last section, but if you can't do them, what they're called the systems of equations in context, don't worry about them. If you can do these, this is what counts. All right, I'm going to erase this now. And start talking about our next section, chapter 4 in the book. And it's all about working with polynomials. That's what our next topic is going to be. Let me mention about, before I go on, let me just tell you about the test that was given on Delta Math. I am going to look at each person's score. If you got all of them correct on the first go, in other words, you didn't try any others, you did one of each kind, you get 100, you're going to see your mark on Blackboard. I'm going to enter your mark on Blackboard. If you had to do a couple of tries, let's say the first question, you tried twice and got wrong answers, but on the third try you got it correct, you will lose. Today I'm going to be very lenient. You're just going to lose a point for each additional try. So instead of getting 10 points for the first question, you'll get 8 points. So if you see something like you got a 98, it meant that you tried 2 problems and you didn't get them right. The next test that I'm going to be giving you, I will be giving you on Blackboard, and I'll tell you it'll be on what we just covered now, Chapter 3, Systems of Equations, and the next chapter, which we're going to be starting today. So our next test will not be on Delta Math. It's going to be on Blackboard as a preparation for the way the midterm is going to be given and the way the final is going to be given. Okay, so let's start with topic number 4, polynomials.
Professor,
Yes.
what if we got like 5 or 6 questions, like you got it wrong 6 times, but then at the end you got it right?
So then let's say you tried it, there was one question, you tried it 5 times until you got it right. Then instead of getting 14 points, you'll probably get 5 points.
Okay, thank you.
So, and I probably won't give less than 5 points, even if it took you 7 tries. I'll stop it at 5 points. But I don't think, I just felt that you have to give some sort of recognition to the people who were able to do it right away. It's a little bit more of a there is a difference between doing it once and doing it 5 times. Okay? Does that seem fair? Okay, let's talk about polynomials. Polynomial. A polynomial is a type of algebraic expression where you have several different terms. Something like this. Negative 4x cubed plus 3x squared minus 2x minus 5. This would be a polynomial. An example of a polynomial. It consists of 1, 2, 3, 4 terms. And notice none of these terms are like terms, because in order to be like terms, the letters have to be the same and the exponents on the letters have to be the same. The variables with their exponents have to be identical. And even though these are all with x's, this one has an exponent of 3 and this one has an exponent of 2. They are not like terms. If you have just one term, for example, like something like this, 8x fourth y squared would be a monomial. Notice all the letters and numbers in my monomial are all connected with the operation of multiplication. There are no pluses or minuses in between them. That makes it one term, a monomial. When there are pluses or minuses between the letters or the numbers, then we get more than one term. There are specific names that we give. We have the name binomial, which means something that has exactly 2 terms. We have something called a trinomial. That has 3 terms. Anything beyond 3 terms, we just give it the generic name polynomial, which means more than one term. And even in this chapter where we're talking about polynomials, sometimes we will also talk about monomials in that chapter, because in order to do things with polynomials, we have to first know how to do things with monomials, with single terms. The word, if you think about it, the word actually tells you what it is. Poly means more than one. Nomio means a number, more than one number. Remember, even though there are letters here, those letters are representative of numbers. So really all we're talking about in algebra is about numbers, and here a polynomial has a bunch of numbers that we're either adding or subtracting. Now, in this chapter, we're going to learn how to work with these polynomials. And a lot of this, some of the beginning is going to be basic that you know already, so I'm going to do it pretty quickly. And then we're going to go into things that are a little bit more complex. First of all, let's talk about adding and subtracting of polynomials. So we're first going to talk about adding and subtracting, then we'll talk about multiplying, and then we'll talk about something called factoring. Actually, dividing of polynomials we are going to do eventually, but it's going to be a little bit later in the term. So let's see if we can talk about adding and subtracting of polynomials. Let's say we had an example like this. Okay. Let's say find the sum of x squared minus 6xy plus y squared and 2x squared minus 6xy minus y squared. I have these two polynomials. The first one, which is x squared minus 6xy plus y squared, it actually happens to be a trinomial because it has three terms. And the second trinomial, which is 2x squared minus 6xy minus y squared. Now, what I usually do when I'm adding is I just put them all in a row together. X squared minus 6xy plus y squared plus 2x squared minus 6xy minus y squared. Okay, so even though it says find the sum of, you really have a total of 6 terms, and you want to collect the like terms, add the like terms, or subtract them depending on whether it says plus or minus, and so that you can simplify your expression as much as you can. Remember, the only things that you're allowed to add are what we call like terms. That means that the variable part, the letter part, the letter parts have to be identical. The only thing that can be different are the coefficients, the numbers in front. And when you're combining them, you just combine those coefficients. So if I have, let's say, an x squared here, the only thing that's going to be like it is something that's just another plain x squared. Well, there's an x squared and a 2x squared. Notice when there's no number in front, it's understood to be a 1. So the coefficient here is 1. The coefficient here is 2. When we add 1 plus 2, that gives us 3. So my first term is 3x squared. The next term I see is negative 6xy. The only thing I can add that to or combine that with is something that has just an x and a y, which I have over here. This term and this term are like terms. The coefficient of this is negative 6. The coefficient of this is negative 6. -6 plus -6 gives me -12. Don't make the mistake of saying -6 cancels out with -6. They're both negatives. When you add two negatives, you add the numbers and your answer is negative. So it's -12xy. Notice I'm not doing anything to the letter parts. I'm just adding the numbers in the front. And finally have a y squared, a positive y squared and a negative y squared. Well, this is a 1 and this is a -1, and 1 plus -1 is 0, cancels out. So my final answer doesn't have any y squared in it, because I usually don't write 0 or 0y squared. 0 times anything is 0, and I just don't have to put it in. I'd only have to put it in if the whole answer would be 0. So my final answer for this particular example would be 3x squared minus 12xy. If we were doing a subtraction example as opposed to a addition example, let's say I gave you something like this. Suppose I give you this problem and I said it either will say simplify or subtract or something. So it says in parentheses y to the third minus 2y squared minus 3y plus 4 minus 2y third minus y squared plus y minus 3. In this example, we are subtracting two polynomials. These are two polynomials that each consist of 4 terms, so they don't have a special name. Just as a matter of interest, both of these polynomials happen to have just one variable. They have the variable y. The highest exponent that I'm seeing in this polynomial, in each of these polynomials, is an exponent of 3. This has an exponent of 3, this has an exponent of 3. We sometimes say that the polynomial is a third degree polynomial. The degree of a polynomial is the highest exponent that you're going to see. Now, if you happen to have two variables, then you have to add the exponents together to get the degree. I will only talk about degree when it applies to single variables. And again, it's the highest exponent. A third degree exponent, a third degree polynomial will have an exponent with a 3 in it. That'll be the highest exponent you'll see. Also, if you notice, these terms, the exponents keep going down and down and down. It starts with an exponent of 3, then an exponent of 2. This one has no exponent, which means its exponent is 1, and this doesn't even have a y in it. This is what's called descending order. We have our polynomials. Usually that's what we do. We put our polynomials in descending order. None of this is so important, but it's just a matter of, it looks neater when it's done that way. Okay, the only difference between adding two polynomials and subtracting two polynomials is you're subtracting coefficients rather than adding them. Now, I think the easiest way to do something like this is remembering if there's a minus in front of an exponent without any number, it's understood as if there's a number 1 there. And then, so there's a number 1 here and a negative 1 over here. Remove the parentheses, remembering if there's a positive 1, you just leave it, y cubed minus 2y squared minus 3y plus 4. And this one, I'm multiplying by negative 1, that will become negative 2y cubed plus y squared, because I'm multiplying everything by negative 1, minus y plus 3. So first remove your parentheses, and then you can look for your like terms. Now it's just like what we did before. We have a y cubed here and a negative 2y cubed here. I can combine this. This is a 1 and a negative 2. That gives me negative 1 or negative y cubed. Now I have a negative 2y squared and a plus 1y squared. So again, negative 2 and 1 gives me negative 1. So it's negative y squared. Now I have the y's. I have a negative 3y and a negative 1y. That gives me negative 4y. And finally, I have a 4 plus a 3. That gives me plus 7. So I collect the like terms, again, combining their coefficients, being careful with the signs. Most people, if there's mistakes made, it's because they're not being careful with their signs. If you make mistakes adding, subtracting sign numbers, make sure you take your calculator and do it with your calculator so you don't make those mistakes, because those are mistakes that on a multiple choice test are going to give you the wrong answer, but you probably know what you're doing anyhow. So it's, at least be careful so you don't make those type of mistakes. I'm going to give you one to try now to see if you know how to do this. Okay? Actually, it's one of the examples on the practice sheet 4. It happens to be question number 3. Subtract 3x squared minus 5x plus 2 from 7x squared plus 2x minus 9. You might have noticed that I did send out practice sheet 4, so that's where this is coming from. Giving you a couple of minutes to try this. So let's try to do this together. Be very careful when it says subtract this from this. English and math don't always set up exactly the same way. If I say subtract 7 from 10, what I'm telling you to do is 10 minus 7. To subtract 7 from 10 means to put the number that you're subtracting at the end. So when this says subtract 3x squared minus 5x plus 2 from 7x squared plus 2x minus 9, what has to go first, the polynomial, actually the trinomial that goes first, is the 7x squared plus 2x minus 9. And then we minus what we're subtracting, the 3x squared minus 5x plus 2. And again, remembering this is as if it's a negative 1. So this will become 7x squared plus 2x minus 9 minus 3x squared. Negative and negative becomes plus 5x. And negative 1 times 2 is minus 2. Okay, now combine the like terms. 7x squared and negative 3x squared is 4x squared. 2x plus 5x is plus 7x. And negative 9 minus 2 is minus 11. Your answer should have been 4x squared plus 7x minus 11. Your answer is a trinomial. Notice we do have our terms in descending order, and the degree here is 2. That's just as a reminder of what we said before. So that takes care of adding and subtracting of polynomials. Remember, you have to collect the like terms and only combine the coefficients. We never touch the exponents or the letters when we're adding or subtracting. So let's go on to multiplication. And I'm going to talk about multiplying of monomials first before I go on to polynomials. Suppose I have 3x squared y fourth times, now sometimes there's a dot in between them, sometimes we just put them in parentheses. Let's just put them in parentheses this time. Suppose I have 4x7 y2. This is one monomial, this is another monomial. When there are two parentheses right next to each other and there's no plus or minus in between them, the operation is understood to be multiplication. And the way we do this is we multiply the coefficients together first. Negative 3 times 4 gives me negative 12. And then we start working with the letters. There's an x squared here. So I look if there's another x term that I can multiply it by. There's an x to the 7th. Now notice you do not have to have like terms when you're multiplying. That's just for adding and subtraction. When I want to multiply two variables together, what I do is I add their exponents. I'm sure you remember this. This has an exponent of 2, this has an exponent of 7. The reason that is because this tells me I'm multiplying x squared means x times x. I'm multiplying x twice. X to the 7th means I'm multiplying x 7 times. So if I take 2 times and 7 times of x's multiplied together, the total I'm going to have is 9. So therefore, I add the exponents. Remember, if a letter doesn't have an exponent, it really is understood to have an exponent of 1. So therefore, I'm going to get, for the x's, x to the 9th. Then I go to the y's. I have a y fourth times a y squared. I add the 4 and the 2, and it gives me y to the 6. So when we're multiplying monomials, we actually multiply the coefficients, the numbers in front, and then we add the coefficients. Now, what happens if we want to multiply a monomial by a polynomial? For example, what if I gave you this? I want to multiply x to the 4x to the 3rd times 5x squared minus 3x plus 1. We're taking a single term in monomial and multiplying it by a polynomial. Well, the way we do that is by using the distributive property. We have to take this 4x cubed, which is a single term, and multiply it by each of the terms that are inside the parentheses. So first I'm going to multiply 4x to the third times 5x squared. So the 4 times the 5 will give me 20. And remember, with the exponents, I'm going to add them. So 3 and 2 is 5. So it's 20x to the 5th, my first term. Then I take the 4x cubed and multiply by the negative 3x. So 4 times negative 3 is negative 12. And x to the third, this is really an x to the 1. It's understood that there's a 1 exponent here. If the letter has no exponent, it means its exponent is 1. So 3 and 1 gives me 4, so this is 12x to the 4th. And finally, I have a 4 times the 1, which gives me 4. And there's just the x cubed. There's no x's over here, so I just bring around across the x cubed. And my answer becomes 12x to the 5th minus 20x to the 5th minus 12x to the 4th plus 4x to the 3rd. Any questions about that? Okay, let's see. I'm going to give you one to try, and then I'm going to say that I'm going to just remind you what you have to do for homework. Okay, let's see if you can do this example. Negative 5, a squared, b squared, times 8a squared minus 2ab plus b squared. I'd like you to multiply this monomial, this is a single term, by this trinomial and get your answer as simple as you can. Okay, let's finish this off and then I'll let you go for the day. Multiplying negative 5 times 8 will give us negative 40. The a squared times the a squared, well, I'll add 2 and 2, that'll give me a to the 4th. And just bring the b squared over because the b squared doesn't have another b to multiply by. Then I do negative 5 times negative 2 is plus 10. The a squared times the a, remember this has an exponent of 1, 2 and 1 is 3, so it's a to the 3rd. And b squared times b, again, this is 1 and 2 is b to the 3rd. And finally, negative 5, well, this is understood to have a 1 in front of it, so that's a negative 5. A squared will just bring over, and b squared times b squared is b to the 4th, and this would be your answer. We will continue next time with multiplying of polynomials and what we call factoring of polynomials. So we're going to start remembering how to multiply, let's say, two binomials together. Here we did a monomial times a polynomial. What happens if we have a polynomial times a polynomial? That's going to be our next session. Have a nice weekend, everybody.